This is number 13 from review test, unit 13, review test B. If you're just looking for the answer, you can go ahead and go to the end of this video and the answer will be there. But if we're trying to figure out how to do this, so it helps to just have a graph here or some sort of sketch. So I've just put up the days that we know, and I could even label this. This is days, and this is hours of sunlight. So we know that the high point is on June 21st, which is the 172nd day of the year. That's the high point for amount of sunlight. And then December 21st, the 355th day of the year, that's the low point for the amount of sunlight. So a couple things that we can start with here. One is we can find the midline. The midline is always the average of the highest and lowest points. And you could convert both of these things into minutes and do it that way. And that might be the easiest way to do it. You can also do it in terms of hours. So here's so 22 minutes is 22/60ths of an hour. And then that over 2. And I think if you do it on your calculator, I think you got, I forget, maybe 2.15, something like that. Or sorry, 12.15. But just in terms of a fraction, it's 12 and 9/60. So that's the midline, and we can draw that here. And then the amplitude is just how far up or down we go from the midline. So I think that the easiest way to do that, just given these numbers, if I go from the top to the midline and find that distance, that's 2 and 13/60ths. Okay, so we've got the midline and the amplitude. Sorry if you can hear the phone ringing in the background. Okay, next thing is period. Well, this is 183 days. So that's the down part. If you doubled that to get the up part, it would be 366. But really, this is meant to be about 1 year. That's really the period over which this happens. So realistically, the period should be 365 days. And from that, we can find B. So if we're thinking about the things that we actually need to make the equation, we need the midline, the amplitude, the period, and then to find B from that, and then the horizontal shift. So to find B, we can do period equals 2 pi over B, multiply both sides by B, divide both sides by 365, and we get B equals 2 pi over 365. So we've got midline, amplitude, and B. And the trickiest thing on a lot of these is the horizontal shift. So if we're doing this in terms of cosine, it's actually not tricky. Cosine starts at its highest point. The highest point's on day 172. So that would be the horizontal shift if we're doing it in terms of cosine. So for that, we would do, and I'll write this in proper function notation. So hours of daylight as a function of the number of days equals, all right, amplitude is 2 and 13/60ths. We're doing this in terms of cosine. B is 2 pi over 365. And then not theta in this case, but D, the number of days, minus the horizontal shift is 172. Plus vertical shift midline, which is 12 and 9/60ths. So it's not easy, but doing it in terms of cosine in this case, because we know where that high point is, we don't really have to do much work to find the horizontal shift. So that makes that much easier. If we want to do it in terms of sine, so we need to find the point where the graph is at the midline going up. And you might recall from some of the Ferris wheel examples that we did that, I'll put a couple more points here. And so the point that's down here, it would not be at 0 because it wouldn't make, if we know the period 365, then it couldn't go from day 0 to day 355. It would actually be like back here. It would sort of be at day -10, if you want to think of it that way. So you might remember from as we were talking about the Ferris wheel ones or the tide ones. So if this is the period, then it takes half of that time to go up and half that time to go down, which means to get from the starting point to this sort of midline point, that's a quarter of the period. Oops. And then here to there is a quarter of the period. Each of these is, and this is why we have segments when we graph these, each of these is 1/4 of the period. So what that means is that if we want to find where this point is, it would be, we could start here. So that's day 172. Backtrack by a quarter of the period. And that would tell us the location of this point, and that's the one we're interested in, where the graph is at the midline going up. So a quarter of that is 91.25. Oh boy, let's hope that I get this right. Because you know what? I'm going to use Siri here. Hey Siri, what is 172 minus 91.25?
172
there we go.
minus
Okay.
91.25.
80.75. Yes, thought I'd make sure. And so now we have what the horizontal shift would be if we're using sine. And so if we're doing it that way, it would be same amplitude. That doesn't change. The only thing that's going to change is the horizontal shift. Sine, same B. Except now it's 80.75. And same vertical shift. Ideally, you would multiply, like in this case, you'd multiply these parts, or for the sine one, you'd multiply those parts. But either of these would still be the correct equation. And these two would give you exactly the same graph. And that's the important point here, is that these two things would give you precisely the same graph. One's defined in terms of cosine, one's defined in terms of sine, but they're giving us different starting points, and so they would perfectly overlap each other. So either one of these would be acceptable or perfect, really, answers to this question.